All right, this video is about how investigators
November
find the
18th,
source of a fire.
1987.
So,
Like every night on the London Underground, it's packed. A train on the Piccadilly line has just pulled into King's
I feel like a fire at a train station or a subway has got to be like particularly bad.
Cross, one of Britain's busiest stations. The horde of passengers get off, but as they squeeze their way up the old wooden escalators, one passenger notices a strange glow coming from within the escalator.
Ooh,
It's on fire. 10 minutes later, the London Fire Brigade arrive on the scene to what is now a small escalator fire. Nothing they haven't dealt with before. But in a matter of seconds, the entire escalator suddenly ignites, sending
whoa,
a jet of fire upwards and into the ticket hall, killing 31 people inside.
31. That's a lot of people. Why is that escalator on fire? Is that a common thing?
Figuring out what exactly happened here was mind-boggling, and it led investigators down a 7-month rabbit hole until they eventually discovered a unique physical phenomena completely unknown until this point that allowed the fire to behave in mysterious ways. We
All
animated
right.
the entire thing to show you how investigators
This is a good
located the
animation.
source of a fire and how early computer simulations led to the discovery of this gravity-defying effect.
This
Even in a
video is
large
not what I
fire,
expected.
Buildings usually don't burn all the way to the ground. Firefighters normally arrive in time to control the fire, leaving
Yeah,
behind
okay. So this is interesting because my grandparents' house just burned
a scene
down
full of clues and
this past week. Actually, it's not even been a week.
evidence that can lead investigators to the source.
So this
By
is
systematically
interesting to
narrowing
me right
down
now.
the search to the rooms with the most damage, they can start looking at the details. Fire burns upwards and outwards, and so when an object burns next to a wall, it creates a distinct V shape that widens out closer to the ceiling. If the object is
That
slightly
makes sense.
further from the wall, it creates more of a U-shaped burn mark, since the tip of the fire doesn't touch the wall. In a small, simple fire that gets put out early, these burn marks usually point towards an obvious source of the fire. But once a fire spreads to multiple objects, these burn patterns start blending together. On top of that, fire can get pulled towards openings like doors and windows, where the abundance of oxygen helps the fire grow. This can leave
Okay, that makes sense of why the fire's always just billowing out the windows and videos and whatnot.
areas
Okay,
of the room
okay.
looking more damaged than the actual source. Take a look at this room, for example. Is it obvious where the fire started?
Ooh,
can
let's see. Um. Well, if I'm going by what they just said, here's a V pattern and here's a V pattern. I can't really tell what that is, but I can see an electrical outlet here. And then the fire is gonna go. One of these windows is gonna be open, so it's gonna pull that way. The flame's gonna pull that way. So let's see if that's right.
See multiple V patterns, but this area here looks more burnt. It's possible that the fire started here, but worked its way up to the curtain, dropping burning debris onto the sofa. Then eventually, the window smashed with the heat and allowed fresh oxygen to flow in, drawing the fire towards that side of the room. But wait, if you lift up the carpet, you'll see what looks like liquid stains. This can be a sign that something like gasoline was used to quickly and deliberately start the fire.
Ooh, there was foul play.
If an investigator suspects arson, they can send in a sniffer dog, specially trained
What is what does this dog look like? A turtle? Look, it's got like a shell.
to sniff out these kinds of flammable substances. If none of this leads towards an obvious source, the investigators will look towards the objects themselves. When materials reach a certain temperature, the water molecules and other organic compounds inside turn into gas, leaving behind a layer of carbon. This is known as char. As the material keeps burning, it works its way inward towards the fresh, unburnt material, leaving behind a thicker and thicker layer of char over time. And so, by measuring the char depth of similar materials at various points in the room, investigators can build up an image of which areas started burning first. This doesn't give a definitive result, but it can help lead them closer to a possible source. But what happens when a fire defies all of these rules? In the London Underground fire, eyewitnesses reported the fire behaving in strange ways. It wasn't burning upwards, but at an angle, perfectly horizontal to the escalator. This baffled the investigators for months, until they tried recreating the fire on one of the most powerful supercomputers around, Odoo. Just kidding. Odoo is actually an all-in-one business
Oh.
management software that gives entrepreneurs access to more than 45 apps to simplify the daily management.
So I'll let that ad play there, but this is interesting. This video isn't exactly what I thought it was going to be, but now I'm tied in. I got to see what happened to that escalator, and how it is behaving in its weird properties. Was there foul play with the escalator? Because 31 people? 31 people dying. That's a lot of people.
So you'll always know who has paid you and who still owes you money. Perhaps the best part is that it isn't behind a paywall.
Okay, all
You can
this
use it for
is,
free for
I wanted
life with
to.
Odoo's first app offer.
We'll have to see what
Access all
Odoo is
applications at
at
an
a later
affordable
time.
subscription.
What does strength in numbers mean to you?
They'll get a regular ad. Yeah, I gotta get. I gotta get ad blocker.
Covenant Health. Let our strength be yours.
At least I didn't get like an erectile dysfunction ad or something.
Escalator fires on
Okay,
the
here
London
we go,
Underground
here we go.
weren't uncommon. In fact, in the 30 years before the King's Crossfire, more than 400 had been reported.
400?
Although smoking had been recently banned in
What is
underground
this?
stations,
This is in London?
people regularly broke this rule. In the 30 years before the King's Crossfire,
Yeah, it
more
looks like-
than 400
looks like
had been
London.
reported.
That's a
Although
lot.
Smoking had been recently banned in underground stations, people
Recently
regularly
banned.
broke this rule and would often light up just before getting on the escalator. Matches and cigarettes would fall between the gaps, igniting the escalator steps, which were still surprisingly made of wood in many underground stations. The thing is, these fires would almost always go out by themselves. So why did this one go from a small fire
super
to an
fire.
enormous inferno in just
Super
a matter
fire.
of seconds? When investigators opened up the other escalators in the station, they noticed that a large amount of grease had built up. And according
Someone's getting fired. They didn't clean the grease.
to staff, this hadn't been cleaned in years. Normally, this grease on its own would be very hard to ignite. But after years of accumulation, the grease was full of dust, fiber, and debris that had dropped through the gaps after years of operation. The investigators tested this grease on an open model of the escalators and found that it was very easy for lit matches to fall down the gaps, ignite the grease, and start a small fire. But no matter what they did, the fire would always burn vertically and eventually put itself out. There was still something missing. One of the main theories was that the ceiling paint, which was 20 layers thick, had absorbed the heat, ignited, and caused the fire to
20
spread up
layers
the
thick
escalator
of
shaft.
paint?
But
Why?
this went against the witness statements, which claimed that the fire never touched the ceiling at all, and instead stuck to the escalator steps all the way to the top. To determine whether this was even possible or not, a computer simulation was set up using the Cray 2 supercomputer, the only one that existed in the UK. This calculated the temperature and airflow of gas at various points to simulate how the fire might have spread. The result was astonishing. The simulation perfectly predicted that the flames and hot gases wouldn't travel upwards, but instead hug the entire length of the escalator steps.
Why?
This completely defied normal fire behavior, as you would expect the hot buoyant gases to have a lot of upwards force. Here's what's happening. Thanks to the trench-like shape of the escalator shaft and its 30-degree angle, the flame couldn't spread outwards, and so the heat had to flow in the direction of the trench. At first, some of the flames did escape upwards through the gaps, but the majority were forced to travel under the escalator steps. As this stream of hot gas accelerated up the escalator shaft, its pressure dropped, creating a difference in pressure above and below the steps. This gradually pushed the fire over until it started sticking to the underside of the steps. The hotter it burned, the faster it traveled, and the more it stuck to the steps. To witnesses, all they could see was a rather small, insignificant fire halfway up the escalator. But beneath the steps, the hot gases were heating the entire length of the wooden escalator to temperatures well above 500 degrees. Those hot
And
gases
just imagine coming home from work and your escalator is just burning. That would suck.
then funneling into the ticket hall and filling up the void above the false ceiling. What happened next turned this small fire into a disaster. When materials reach a certain temperature, they ignite automatically, causing the fire to spread almost instantly. This is known as a flashover. Eventually, the escalator and hot gases reached this temperature, and in an instant, everything ignited. This sent a fireball rushing up the escalator and into the ticket hall, igniting every surface and filling the place with fire and smoke.
I gotta find out who animated this. This is a really good animation.
The computer simulation had shown this exact effect perfectly, but it wasn't fully believed until the investigators performed real tests on a scale model of the escalator shaft. At first, the fire burned upwards, but after just a few minutes, it started lying down and hugging the floor of the escalator. This brand new discovery was named the trench effect, and it led to a bunch of new safety improvements. All wooden escalators were replaced, and heat detectors
This
were
seems
added to
pretty-
the escalators with automatic sprinkler.
Pretty logical.
Thanks for watching, and I'll see you in the next video.
How old movies tricked us. What's that? That looks cool. I'll watch that one next. Okay, that wasn't exactly what I was looking for, but oh, look how blue my face looks with that. Oh, I'm blue. Oh,